Please confirm that you are able to see the screen. We begin. My screen is reading binomial distributions. We are continuing with the discussion we had last time, where we are talking about distributions. We talked about the discrete. So today we continue with the binomial distribution. Like we did for the discrete, we shall begin by looking at what this distribution is all about. And we are saying that a binomial is an experiment consisting of repeated trials that have only two outcomes, a success and a failure. Two outcomes, a success and a failure. The probability of a success is denoted as P, and the probability of a failure is denoted as Q. So since we say that total probability is equal to 1, so it means that if P and Q are exhaustive, so P plus Q must be giving you 1. And therefore, Q will be 1 minus P. So that is a key relationship there in binomial. Then the properties, as you're working out the binomial, we have the properties of the binomial with property number 1 saying that we have X repeated trials, okay? And each trial results into an outcome that is either a success or a failure. The probability of a success P remains constant from trial, and failure becomes 1 minus P. The repeated trials are independent. Now, a typical example of a binomial is the process of getting a child. I know most of you are at least old enough. Some of you have children already. Others, you're planning to have children. So the process of getting a child, there's a guy I've seen in the media. He has over 40 children. The names, the good thing is that most of the children, he knows the names, but he doesn't know the mothers. So like if he's saying, okay, Fred, I know Fred is my son, but who is your mother? So if you want help, you must come with your mother. The guy has 40 children. So, but he doesn't know the mothers, you know. I think the mothers are like around like 15 or 12. So he knows the names and the faces of the children, but doesn't know the mothers. So what does it mean? It means that this guy could have as many children as he wants, X repeated trials. Like some of you, you have instructions from your clan. You have to have as many children. Others, you know, having very many children is prestige. You're powerful. Your voice is heard much more. If you have like 10 or 15 children, you can give a speech at a function. So you can have as many children as you want. But now the challenge is, what is your aim? There's a friend of mine who has been trying to get a boy child. All his children are girls. He has about 9 children, all girls. So the 10th one, he came and told me, you know what, Professor, I'm going to try elsewhere because I'm really, I need a boy. I told him, but now why are you struggling to look for a boy? Because all these 9 girls are going to bring you boys. So 9 girls, those are 9 boys. Said, no, I want my own boy. So we tried to counsel him. We got for him a professional counselor to tell him to relax. Please relax. You are a Molokole, you are a CFD, you know, this very staunch. Said, no, at least this one, God will forgive me because I've been praying for a boy. So his success is getting a boy. You see that? But now, it doesn't mean that getting a boy, I mean, getting a girl as your 9th child, you won't get another girl. You can get a girl, a boy. Okay? Are you getting the point? So it's just unfortunate that for him, he has failed to get a boy and is trying very hard to get a boy. So after convincing him not to really do bad things, he decided to go behind our back to look for a boy. So the news I have is that he actually got other 3 girls. So those are how many children? Those are 12 girls, not so, if my math is correct. So the guy has failed to get a boy. So he had 9 children in the official wife, and now even going out of the marriage to get another, to try elsewhere. He gets 3 more other girls. Is that kind of thing? He gets 3 more other girls. So he now has, then he, of course, from the other people I've had, he said he has given up. He has accepted the problem is his. So I wanted to call him to ask him if his wife can try elsewhere to look for a boy. Because it looks like the problem of getting a boy is with a man, So how will he feel? So don't do those things, friends. Whichever child God has given you, that's a child, whether it's a boy, a girl, go with that, Yeah. So this man here, I think his intention is a boy, but he has failed. But what we are saying is that kind of an experiment, if I say an experiment, because he decided to experiment. And actually, when he was talking to me, I really saw a binomial. I told him, you man, that's a binomial. It doesn't mean that getting 9 children, you can now it's time to get a boy. You can even get more girls, Or there are other people who have only boys and they are looking for a girl. Especially, I know, some men, by the way, they really dare to have a girl. They don't want only boys. So it doesn't mean that your firstborn being a girl is automatic that the secondborn will be a boy. It's a binomial. You're dealing with a binomial. That's a binomial distribution. And in number 3, we are saying that the probability of a success P remains constant. So it means that man's probability of getting a boy must be almost like 0.00001. It's constant. And the probability of getting a girl is almost, I don't know. The repeated trials are independent. Now the independence comes in number 4. The repeated trials are independent. Yeah, they are independent. The firstborn being a boy. The secondborn can be a boy. It's not automatic. That kind of thing. So unless, I think that's why these white people are trying to, you can turn you, if you're a girl, they turn you into a boy, transgender. If you're a girl, you can be a boy can be a girl can be a boy. I think now that's why the science has gone that way. So just have to relax. Then you use that science to turn whatever you want. But the repeated trials are totally independent. So those are the 4 major properties of a binomial. And I think with my story, you will not forget those properties. Now, As we did for the discrete, we are going to use an exam type question. I think it's around November 2022. November 2022. This should be the question. You check, those of you have the practice and revision kit, you try to check. Now this goes that at Go Back Well Clinic, on average, 20% of the patients in private rooms have health insurance. You see that? To successfully get a patient who has health insurance, the lack is 20%. 20% of the patients in the private rooms have health insurance. Assuming X to be the number of insured patients, and of course, we are looking at 1, 2, 3, 4, and 5, we are required to determine the mean and the standard deviation, the probability that 4 patients have health insurance and less than 3 patients have health insurance. Now, from what we are given here, and from the properties of the binomial as discussed, P is 20%, probability of success. If we are talking about success in that way, Q becomes what now? 80%. That there is an 80% chance to fail to get someone with health insurance. What about N? N will be 5 patients outrightly. 5 patients. Okay. X repeated trials. 1, 2, 3, 4, 5 trials. Okay. 5 trials, 5 patients. We have tried on 5 patients. Patient number 1, we see what's happening there. Patient number 2, patient number 3, patient number 4, patient number 5. 5 observations. So I'm going to give you 3 minutes. Open your books. Let us write this in our books. Notify me when you're done with the activity question so that I unmute and we continue. All right. Let us begin with Roman number 1, mean and the standard deviation. With the mean of a binomial, we are still talking about expectation. Sorry about this. The mean of a binomial is known as the expectation, denoted as EX and given by simply NP. The mean of a binomial, let us write in our books, the mean of a binomial is known as the expectation, denoted as EX, denoted as EX, denoted as EX, and given by NP, and given by NP. Okay, so now let us substitute. According to our question, the P is equal to 20%, which I can say is 0.2. Our Q is 80%, which I can say is 0.8. Our N is 5. So our mean, which is the expectation EX, is equal to NP. So that's going to be 0.2 times 5, giving us about how much? Anybody the calculator there? The mean is equal to EX, the expectation, NP, 0.2 times 5, giving us about how much, friends? Giving us about 1 patient. Perfect. Giving us 1. So, in our conclusion, we are saying that we expect only 1 patient on average to have health insurance. So that would be the meaning or the interpretation. On average, only one patient has health insurance. On average, only one patient has health insurance. On average, only one patient has health insurance. Good. All right, let us go to the second part. Let us go to the second part. Let us turn to the second part. The variance. The variance, let us write down there, the variance. The variance of a binomial distribution, the variance of a binomial distribution, the variance of a binomial distribution is denoted as VARX. The variance of a binomial distribution is denoted as VARX. This is given by VARX is given by NPQ. Variance is given by NPQ. Variance is given by NPQ. Okay. So let us substitute. If our variance is VRX, it's given by NPQ. Our N is 5 times P 0.2 times Q, which is 0.8. Our VARX, which is NPQ, is equal to 5 times 0.2 times 0.8. Okay, anybody the calculator? What do we have here? That gives us 0.8. Perfect. Good. 0.8. So that is our variance. Our variance is 0.8. Okay. Good. Next is the standard deviation. Next is the standard deviation. The standard deviation, you know, is the square root of the variance. So I would be right if I say that the variance is equal to the square root of NPQ. Would be right to say that the variance of a binomial is NPQ. Okay, let us turn to the page. We need the standard deviation. Standard deviation. Okay. Which is also denoted as that is equal to square root NPQ. Let's do that. Square root 5 times 0.2 times 0.8, which is the square root of 0.8, which gives us about how much? Which gives us about how much? Anybody the calculator? Which gives us 0.89, which gives us 0.89, which gives us 0.89. Good. Let us now look at the other concept of the probability in the Next parts of the question, we are required to find the probability. But the question is, what is the probability of a binomial? What is the probability of a binomial? So we are going to write in our books, just below that solution, that the probability, shall write and say that the probability of X successes, the probability of X successes in n independent trials, the probability of X successes in n independent trials, denoted as this. That one you write, you can see on the screen there, denoted by B, X, and P, denoted by B, X, and P, with the probability of successes P, with the probability of successes P, various Q is given by that formula right there. Okay, let us get to that in the next 2 minutes. Let's try that formula on our screen. We continue. So as you can see on the screen, we have nx, px, qn minus x. Nx is n factorial, x factorial, n minus x factorial. Now, what is this factorial notation? The factorial notation, if I say, let's say 5 factorial, I need to do 5 times 4 times 3 times 2 times 1. 10 factorial would be 10 times 9 times 8 times 7 times 2 times 1. 100 factorial would be 100 times 99 times 98 times 97 times 2 times 1. So factorial notation means from that very number to the last number. For instance, people ask me my age. I give them in factorial, whatever. I use factorial. Say, how old are you? I am 5 factorial years. So that kind of thing. I am 5 factorial years. Even when I'm feeding, if I need the national ID, if I need a passport, because it's a way of expressing a number. If I know the factorial, for instance, right now I am, I think I'm 4 factorial. Some of you are 3 factorial in the years. You get that kind of thing? So factorial notation is one way to express a bigger number. So using this, what would be the probability? Now let us go back to the question. Let's go back to the question. If I can take you back to the question, what are we saying? Roman 1 is done. We are done with Roman 1 now. Roman 2, probability that 4 patients have health insurance. Probability that 4 patients have health insurance. So what are we talking about here? We need that probability that X is equal to 4. X is equal to 4. Let us go back. 4 patients have health insurance. Probability X is equal to 4. That was Roman 2. Probability that X is equal to 4. If it is a binomial, then what are we talking about? We are talking about nx, n is 5, 4, into following the formula, p to power x, our p is 0.2, Our X is 4. Q 0.8 into 5 minus 4. So that's going to be 4 into 0.2 to the power 4 into 0.8 to power 1. But 4 is 5 factorial. Oh, wait a minute. Yes, 5 factorial, 4 factorial, 5 minus 4 factorial. It's going to be 5 factorial over 4 factorial into 1 factorial. That's going to be 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, then times 1. So according to that senior for math, this goes with that, leaving us with a 5. Assuming I have a calculator, I think it's even much better that this factorial, you feed it into the calculator. How can I do that? I'm going to share a lecture video on that. I'm going to share a video, YouTube video, to show you how to get the factorial from your calculator. No questions asked. You just feed in 5, 4. That's it. So I'm going to share a video showing the different calculators. I know you have different calculators. At least the Casio Scientific is the most common in the market. I will show you that. Without even struggling a lot, you can just put in 5, 4. 5, 4. To give you the 5 factorial. So if we substitute, we are going to get, if I substitute right here, it's going to be my 5 times 0.2 to the power 4 times 0.8 to the power 1, which is about how much? Which is about how much? Hello? Anybody there? Anybody? Anybody? KMT? But now stop naming yourselves KMT. KMT. Now I don't know now this one, KMT. But I can see even this admin. I don't know is really called admin. But I can see Amuhere Fred. That's very nice. Faith Adongakulu Amolo. Judith is there, but now Judith, you also have to add another name, your second name there. Martha Komohanji, Maureen, I don't know whether it's Maureen, whatever, I don't know now. You need to add. There's JB Moksa, I can see that. In Patience in it. Peace. You have to add another name. Rachel, you see, adding another name will help. You know, I told you guys, you never know who you'll meet somewhere. So if you call yourself KMT admin, now you won't have OBs. They will ask you, is your OB? Is your OG? You don't know. So anybody giving me the probability, I can see Patience in it, 0.102, 0.1024. Samuel team, do you agree with that? Tino, is that okay? Kokasi? Oh, Kokasi is giving us 0.0064. Interesting. Rachel confirms it. Kokasi, I think Patience in it. You see where two people are getting the same answer. It means you need to check yourself. Any other person to confirm that 0.0064? All right. You made an error. That's okay. Correct that error so that we have the same answer. So the probability that 4 patients have health insurance is actually 0.0064. 0.0064. All right. Next, finally, we want the probability. If I go back to the question, just bear with me. I want to pick up that question. In Roman 3, less than, we are done with Roman 1. We are done with the first part. Second part now, Roman 3, less than 3 patients have health insurance. Less than 3 patients have health insurance. Okay, so less than. So looking at the number line, considering the figures given to us, less than 3 patients. So I would be right if I say this is probability x is less 3. And where are we less than 3? Probability that x is less than 3 would be at probability that x is 1 plus probability that x is 2. So that's going to be 5,1 into 0.2 to power 1 into 0.8 to power 5 minus 1. That is the first part of the 1 plus now the 2 is going to be 5,2 into 0.2 to power 1 into 0.8, 5 minus 2. Oh, this is to power 2. Okay, so give me the value of A and the value of B, and then the total C. Those are the answers I want from you in the next 5 minutes. What is the value of A? This A here, this one. How much is this? Anybody with something? 0 point? Yeah. 0 point? 0.4, 0.4096. Good. Then here the B. The B is 0 point. The B is 0 point. The B is 0 point. 0.2048. Now, when we sum up, what do we get in total? 0.4096 plus 0.2048. That gives us about how much? 0.6144. Good. So that is our binomial. Finally, we have where we shall begin next Tuesday, binomial approximation to normal. Now, we cannot do binomial approximation to normal before looking at normal distributions themselves. Okay, so we shall begin right here. We shall cover normal. Then we look at binomial approximation and then wind up with Poisson distributions. That is on Tuesday next week.